All right, so as we talked about yesterday, right, today is day 2 of simplifying expressions. And so when we simplify expressions, yes, we have to combine like terms, but so many times we're going to see the distributive property. So many times we're going to see the distributive property. This one actually doesn't have any sort of mathy blurb before it. It's truly just A times B plus C is equal to AB plus AC. The annotation that I'm going to want to see whenever we distribute is that we're taking A and multiplying it to both B and C. And so the key here, multiply whatever is outside to everything. This is what I want to be really careful about. Inside. Whatever's on the outside, you multiply to everything on the inside. And so if you have a giant expression on the inside, yes, whatever's on the outside needs to be multiplied to every single one of those terms. Now, we're also including here perfect square. Perfect square is what we are going to need for float. A perfect square is simply a number that can be expressed as one integer times itself. A number that can be expressed as one integer times itself. First few that we see and know pretty well. 1, 4, 9, 16. There's definitely more after that, but again, any number that is the result of squaring an integer. That is what we are looking for. 1 squared, that's 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. So on. Once you've got these both, flip your notes so that I can see, please. Really, thank you for there. That was there. Thank you. Couple still writing, that's totally fine. Take about 10 more seconds to definitions, and I'm going to scroll away. All right. So, example 1. Pretty basic. I got 6 on the outside of x plus 2. So I know that this is really 6 times the quantity of x plus 2. I'm going to distribute. I'm going to get 6x plus, well, everybody, what's 6 times 2? 12. There it is. Okay, what question?
For example 2, yes.
We'll talk about example 2 when we get there. And so again, example 1, fairly basic. Just looking to have the 6 be multiplied in. That's all. Now, example 2. A little bit more going on, but a few things that we have to be really careful about. First, raise your hand. What number do you think I should be distributing? Gabby. Say it again. -2. The key there is that we need to include the negative. And so, I'm actually going to draw a circle. Actually, I'm going to change so that I'm not blocking the entire problem. Like that. That -2 is now what we distribute to both of these terms. But I also want to be clear that it is just the -2. I am not distributing the 5x. I am only distributing the number that is touching the parentheses. And so when I do this, I'm going to get 5x, okay, -2 times a +4, that's -8x. -2 times a +5 minus 10. And from here, I just have to combine my like terms. 5 minus 8 is going to give me negative 3x minus 10. Anytime we distribute in a negative, all of the signs inside of parentheses need to change. And so notice, we distributed the negative. Everything started as positive. Everything turned into a negative. Started as positive, turned into a negative. Any questions on example 2? All right, then we're going to roll right on through. Take a look at example 3. Now, again, even more going on here. And so not only do we now have distribution of a positive integer, but we now have distribution of a negative fraction. Well, let's take a look. First thing I'm going to do, this 3's got to get distributed, and then this negative 1/3 needs to be distributed over here. On the left, it's a little bit easier, right? It's just a 3. And so 3 times 3 is going to get me to 9k minus 6. But now I have to deal with this fraction. Well, I know, right? If we think about this off to the side a little bit, if I have negative 1/3 times 12, raise your hand. How would I turn 12 into a fraction, MJ? Yeah, I'm going to put a 1 under it. And so when I multiply like this, I'm actually just multiplying the 12 by the numerator, right? And so I should end up with negative 12 over 3. Well, that's going to be the pattern that I actually end up following. I know that when I distribute in a fraction, I'm really multiplying whatever's there by the numerator of that fraction. And so I'm going to have minus 12 over 3k minus 9 over 3. Again, just multiplying the terms that are there by the numerator. Now, from here, this is a few extra steps to clean up. But luckily, it's going to clean up really well. Now, the 9k minus 6, I actually can't really do anything with until I deal with the fractions. And so raise your hand. What does 12/3 turn into, Gabby? Negative 4. So I've got negative 4k minus, raise your hand again, 9/3 is, Carl, 3. Oh, well, even though I had what looks like bad fractions, it's actually just integers. And so now, I've got like terms. Okay, I've got 9k minus 4k, negative 6, negative 3. 9 minus 4 is going to get me to 5k. Negative 6 minus 3 is negative 9. For a final answer. All right, here's some people already starting. Before we get too far away, are there questions on example 3? All right, you're already doing it. Fold your notes. Get them glued into your notebook, please. You got 1 minute. Go. And make sure you're gluing, make sure you're screwing your glue stick back down before capping it. If you don't, when you cap it, 2 things will happen. 1, all of the glue will squish out the sides and you'll destroy it that way. Or 2, as some people have noticed, the actual glue portion will just be stuck in the cap and it'll instantly ruin the glue stick. All right. Take about 5 more seconds. Firmly press this in there, set it aside to dry.